So hello people, so today we'll be solving LeetCode daily question 1535, that is find the winner of an array game, and in this we'll be given an integer array of distinct integers and an integer k, and a game will be played between the first two elements of the array, that is 0th element and the first element, and in each round of the game we'll be combining the 0th and the first element of the array, and the largest integer wins, and it will be remaining at the position 0, and the small integer moves to the end of the array. It means that the array will get rotated, okay, and the game ends when an integer k wins when any integer wins k consecutive rounds, okay. So and will be the returning the integer which will win the game, okay. And okay, it is mentioned that we'll be definitely finding a winner of the game. Okay, so let's see the test cases. In the first test case, we are given that input is 2, 1, 3, 5, 4, 6, 7, and we are given k is equal to 2. Means that any integer needs to win 2 consecutive games, so that will be the winner. Okay, so in the first case, let's see that. Okay, let me just copy this and move to the explanation. Uh, okay, so yeah. So in this, okay, we'll are having an array as 2, 1, 3, 5, 4, 6, 7, and k is equal to 2. So any integer needs to win two consecutive times to win the game. Okay, so in this the output is 5. Let's see how the output is coming out to be 1. So in the first case, we'll be comparing 2 and 1. So as 2 is the winner, so it will remain at 0th index, and let's say the win counter currently is 1. In the next round, we'll be comparing 2 and 3. Okay, so as 3 is greater than 2, so 3 will be remaining at the 0th index, and now the current counter again begins to be 1. Then we are having 3 and 5, so in this case that 5 will be winning, so we'll be having current win counter as 1. Okay, so in the next case we'll be comparing 5 and 4. So in this case 5 will be winning the game again, okay, as 4 is smaller than 5, so we'll be having current counter win counter as 2, and as current win counter is 2, so that means k is equal to 2. So now we'll be returning 5 as the possible answer. Okay, so this is how what we'll be doing, and in the rest of the cases we can see that when one loses, it is moved towards the last and the arrays move forward. Okay, so and next in this case the 3 is moved towards the last. Okay, no, so sorry, 3 is the winner, so 3 is moved here and 2 is come to the last. Okay, in the next case 3 and 5, 3 is again the loser, so 3 will be coming here, okay, and the array will be coming forward. Okay, so this is how we'll have to approach the question. So let's directly move to the coding window as there is. Okay, so let me explain one edge case, that if k will be greater than the length of the size of the array. Let's say the size of the array for this is 7. When k will be greater than or equal to 7. Okay, so in this case what will be returning the maximum element of that array. Why maximum element? Okay, return max of the array. Okay, so why we are doing this is because if let's say we start with any integer, let's say 2, and if we are given k is 10, so in 2 1 comparison 2 will come here, but then again it will lose. Similarly in 1 3 comparison, one in then 2 3 comparison 2 will lose, so it will come back. In 3 5 comparison 3 will lose. 5 4 comparison it will win, so the current win counter will be here, it will be 2 in case of 5. Okay, 2. But next in the case of 5 and 6, the win counter will become 6, will win counter will again become 1. In case of 6 and 7, the win counter will again become 1. But when 7th is will be present at the 0th index, we'll be having continuous wins of till n times. Okay, so that's why we'll be returning the maximum. So now let's move towards the coding for this. Okay, so what we'll be doing, we'll be checking the first edge case, that if k is greater than or equal to arr.length, what we'll be returning arrays dot string arr dot max dot get as end. Okay, so this is what we'll be doing. Otherwise what we'll be doing, we'll be checking that we'll be having two variables, let's say maximum element okay, and max element that will be set to 0, ARR 0. Okay, or what we can do, we can just simply get the maximum element from here. Okay, so why we don't use this is because the time complexity for this is very high. So, but in this case, I'm just compromising on the time complexity. You can also use the regular method for like using the for loop. Okay, or let's just do that way. Let's say first maximum of the element is 0. So for and I in max ELE. Oh, okay, and sorry. ARR, what we'll be doing? Max ELE. Max element will be equal to math dot max I comma maximum element. Okay. So after this, what we'll be doing? We'll be having current element. Let's say ARR 0, and then what we'll be doing? Current streak. Okay, that is winning streak. That will be firstly initialized with 0. Okay. So now again for loop, and I equal to 0, I less than ARR dot length I plus plus. So what we'll be doing, that let's have a variable temp that will be basically the ith element. Okay, here it should be, we'll be initializing the array from for loop from 1, sorry, not the array, I equal to 1. So first we'll be checking that if current is greater than the temp, so we'll be doing streak plus plus. Else what we'll be doing, that if it is smaller than this, what we'll be doing, current will be equal to temp and our streak will be set to 1. Okay, so in the other case we'll be checking that if streak is equal to k, or our current element becomes the maximum element, we'll be returning current. Okay, or in the other case what we'll be doing, we'll be just simply returning -1. Now let's submit it. Yeah, and it gets accepted. So now let's submit it. Yeah, and it will get accepted. The time complexity issue is basically for because of the edge cases, that because this function basically uses a lot of time complexity rather than this standard method. Okay, so okay, this was it for today. Thank you for